We are going to look for a few minutes at examples of changing velocity. So let me draw two examples. You can tell the velocity graph is changing because the graph will slant. It won't be flat. So here's an example, and here's an example. Notice they both slant downhill. So you would think they must be similar, but they're actually quite different. In the first graph, notice that we start up high on the axis. This point is telling me it's not the initial position of the object because this is not a position graph, it's a velocity graph. So this intercept here is actually the initial velocity. So I'm going to say initial velocity, and I'm just going to write very positive because it's in the top quadrant and it's really far from zero. All right, remember that what this means, positive means it's moving away. So I'm going to write away quickly. I know to use the word away because it's positive, and I use the word quickly because it's so far from zero. But notice, as this graph continues, I'm going to go to the end of the graph, and I'm going to say VF, that's the final velocity, and it's on the zero bar. Okay, the final velocity is zero. So I was moving away quickly, but by the end of the story, zero means that I'm not moving. So this object clearly has slowed down. And I can see that just by looking, this graph is moving towards zero. That means it's getting slower. So, for this graph, I would say the object is moving away from the reference and slowing down. And that would be how I describe this object. The second graph is different. Notice the initial velocity here at the beginning is on zero. That means that the object starts at rest. It wasn't moving at all. But by the end of the graph, my final velocity is very negative. I said negative because we're in the bottom quadrant, and I used the word very because we're so far below the zero bar. What this means is that the object is coming towards the reference quickly. So this object starts at rest, but then by the end of the story is moving towards the reference quickly. If you think about that, this means the object is gaining speed. I can see that by looking at the velocity graph because notice that this graph slopes away from zero. It's getting further and further from that center axis, which means it's getting faster. Okay? So the first graph was slowing down, and the second graph is gaining speed. The first graph was going away from the reference because it was in the top quadrant, and the second graph was going toward the reference because it's in the bottom quadrant. So if you have a slanted velocity graph, what you need to look at is it in the top quadrant or the bottom quadrant? And does it slant towards the center zero, or is it slanting away from the center zero? And if you look at those qualities, you can easily identify what is happening to the object in real life. Remember that the slope of your velocity graph is related to acceleration. Both of these graphs were going downhill, so that means that both of these graphs are examples of negative acceleration.